Hello everyone, welcome to Practical Mechanics. I'm Mohsen. Today's video we learn how a straightness tolerance can be applied to a feature and feature of size. How to calculate geometric tolerance at MMC, maximum material conditions, using a modifier. Let's start with an example. Here there is a shaft. The drawing is given, diameter is between 9.8 to 10.2. Before geometric tolerances, this drawing was enough to give to the manufacturer by designer and ask them to produce the part that they asked for that drawing. Sometimes it happens that the parts return back to the designer after production with some geometric defects similar to this form. I draw it a little and like this and like this and like this, or like this. These are 5 geometric defected form that designer cannot accept them. When he asks manufacturer, I cannot use them. This is bended, this is barrel, this is random shape, this is wasted, this is tapered shape. Manufacturer told that I measured all of them and all has the diameter. For example, this minimum was 9.8 and this maximum here was 10.2. What's wrong with that? Nothing. Here also at the same local is between 9.8 to 0.8. Here this is 9.8 and here this is 10.2. What's wrong with that? Here this is 10.2 and here this is 9.8. Here this is 9.8 and here this is 10.2. You give me these sizes and I produce at these sizes. What's wrong with them? You cannot complain. Say that I mean the form. This drawing doesn't give anything about the form. Just give the sizes, 2 sizes, minimum and maximum diameter. Geometric tolerance is to control these forms. Not only with thrust on size, but on geometric size. But the size tolerance, not only with thrust on size tolerance, we have to trust on geometric tolerance as well. Geometric tolerance talks about the straightness. It says that if I choose one line from external surface of the part and test it, it must lie between 2 parallel lines. I give you a zone. A zone is a space between 2 parallel lines. How much is this zone size? You say, for example, 0.2 mm. Then any line that I choose from external surface must lie between 2 perfect parallel lines. How you can choose it? By check it by CMM machine, for example, or by optic machines. Okay. Then, in this case, how I can tell to manufacturer, send a message to manufacturer, be careful about the line on the external surface or surface element, other name. I draw a box, which is called feature control frame, and then a straightness symbol, and point to geometric tolerance and apply that to a feature surface. This is feature contour frame composed of two compartments, and this is lit that says that this apply to what? This here apply to a feature, only a surface. It means manufacturer. Any line on the external surface of this part can be taken out, and we test it between two parallel lines that they are 0.2 millimeter apart. If that's okay for all lines, then we accept the part. Maybe it doesn't work here. Straightness doesn't work here. Maybe the line that you choose or select is straight, but the form is not acceptable again. We control this one by another geometric tolerance that we talk about it later, which is called cylindricity. Then cylindricity controls the taperness of a shaft, not the straightness. Let's cancel it here. We just consider these four forms. Sometimes designers want to check the straightness of the axis as well. How send a message in drawing that we control the axis as well. How you can control the axis? By derived median points. What are derived median points? I give the part to CMM machine stylus touch here, send the coordinates to computer, and then come opposite to that 180 degrees under it, touch here as well, and send the coordinates as well, and find the midpoint between them. For example, here. This is called derived median point. And do it from the first to the end of the shaft, and we have a set of points. These points are in all direction, and they are not only up and down, they may be back and forth, and in any angles. Then this is a 3D configuration. How you must check this axis. In CMM machine, you draw a narrow cylinder that contains all these points. Okay? All these points, derived median point, must lie inside a narrow cylinder. Around what? Around the ideal axis. These points represent the axis of your product. Okay? Then, size of this narrow cylinder is your geometric tolerance. How much is it? Space inside that is zone shape. Size of diameter is zone size. Then, how I can send a message that I wanted to check the axis. The axis also will be checked through our feature control here, straightness tolerance. Phi that shows that there is a cylinder zone and point to here. It means that all axes must lie inside a narrow cylinder. As long as the axis lies inside the narrow cylinder and diameter of that axis is 0.2, the part will be accepted. Otherwise, the part will be rejected. Then, they say that the straightness apply here to a feature of size, means there is a feature accompanied with the size. And how you differentiate these two together, this apply on the feature, is not accompanied with the size, but this must be accompanied with the size. One method is show under size, another method is show besides the size, another method just I show it here and connect it with the lid to the dimension line. Connect it to the dimension line. That's the third method. How we show that we mean straightness must be applied to the axis. Okay. Then this is the straightness and how to apply that to an axis. Later, we talk about M modifier and the use of M modifier with straightness tolerance in the next video. Thank you for watching. Bye now.